Well, hi everybody. Gonna make a video of the solutions of the practice test 1 for your references. So, first one is a piecewise function. Let's evaluate for these particular values. F of -7 falls with that one. That's less than or equal to -1. So I'm going to take -7 minus 2, and that equals -9. F of 1 falls between -1 and 3. So I'm going to take 3 times 1 minus 2, using that middle piece. 3 minus 2 is equal to 1. And F of 3, it falls on the middle one again. It's not greater than 3. It falls on this one. So I'm going to take 3 times 3 minus 2. 9 minus 2 is 7. Now we have to graph it and then give domain and range. So the graph here, we will okay, I'm going to graph this piece first. And I'm going to start with -1. I'm going to put a solid and less than. That's -2, -3. -1 minus 2 is -3. -2 minus 2 is -4. -3 minus 2 is -5. So -1, 1, 2, 3 is here. -2, 4 is here. -3, 5 is here. So this piece is going like this. I have kind of dividing 3 parts to this at -1 and at 3. So let's look what this middle part's doing. And I'm going to go from -1, but understanding that's going to be an open circle at -1, and then 0, 1, 2, and 3. 1, 2, and 3 gets the solid circle. -3 minus 2 is -5. 0 minus 2 is -2. 3 minus 2 is 1. 6 minus 2 is 4. 9 minus 2 is 7. Alright, so -1, and that's linear. -1, -5 is right there. 0, -2 is there. 1, 1 is there. 2, 4 is there. 3, 7. 5, 6, 7 is right there. Open circle there. No, closed circle there. So I'm closing that in. Alright. I got x, and x squared minus 6x plus 8. I'm starting with 3. There's an open circle at 3. Then I'll do 4 and 5. Let's look at those are. 3 squared minus 6 times 3 plus 8. Easier to look at. 9 minus 18 is -9 plus 8 is -1. 4 squared minus 6 times 4 plus 8. That's 16 minus 24. So that's -8 plus 8 is 0. Let's try 5. 5 squared minus 6 times 5 plus 8. That's 25 minus 30. That's -5 plus 8 is 3. So I'm put a point at 3, -1. That's open. closed there because this is a function. 4, 0 is here. 5, 1, 2, 3 is here. If I were to continue, might be right around there, but I'm curving upwards right around here. All right. Domain, there's no break here because of the solid circles. You might think, oh, we got a gap here, but this gap overlaps, and this goes from here. So we can have all values of y as solutions there. So that's the domain and range. All right, I'm reaching for my calculator to do the next one here. Okay, found it. Now, so determine the open intervals for which f of x equals the absolute value of x minus 3 plus the absolute value of x plus 2 is increasing, decreasing, or constant. All right, so I'm going to go math to get the absolute value of x minus 3 let me go past that, x minus 3, then plus absolute value of x plus 2. All right, there we go. Now let's graph that. Oh, I'm on a bad window here. I'm not seeing it. So I'm going to go zoom 6. You may already been on that window. Okay. Now, this is negative 2, 5. And this is 1, 2, 3, 5. You can trace for that, but I'm pretty sure that's negative 2, 5, and that this is 3, 5. So what we have is a decreasing part right here. So I need to identify that. From the far left until I get to negative 2, and it said describe the open intervals, so that's why I'm using a curved bracket here. And then, if you'll notice, we're horizontal right there. So that is constant. And I'm only writing the x values. And that's from negative 2 to 3. And then increasing, if you notice, picks up at 3, and it's increasing after x is 3. Okay. All right. Number 4, we're going to graph this, find all the max, all the mins, and the intervals for which f of x is greater than or equal to 0. So graphing calculator is very important. Got to be able to graph these functions. So just keep that in mind. Negative x to the third minus 2x. Oh, okay. Here's something I do a lot, and I don't mean to, but okay. Negative x to the third. Okay, now I got to bring the cursor down because it'll stay up in the exponent if I don't. Minus 2x squared plus 3x plus 2. And graph that. Okay. Now, I see a minimum, well, I see a maximum right here. That's A is max. So I'm going to go second, then the trace button, second calc, and get that maximum, that relative max. There's a good left bound. Enter. And I'm going to turn the cursor to the other side of that high part. Hit enter. And then guess. And I'm going to write, I'm going to point 535 is the x coordinate. And the y coordinate, I'm getting 2.879. Rounding to 3 decimal places right now. Second calc, I want that minimum. It's right here. I need to get this thing left of that. So I'm going to hit the left button until I'm on the other side of that. Okay, enter. 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 I'm seeing the coordinates of that point are negative 1.869, negative 4.065. Okay. The intervals for which f of x is greater than or equal to 0. Right here. From here to here, we're above the axis. From here to here, we're above the x-axis. That's when f of x is greater than or equal to 0. So I want to find this 0, and this 0. So we got to find zeros there. Second calc, 0. I got to be left of that 0, enter. I got to be right of that 0, enter. Guess, enter. Negative 2.814. Okay. From negative infinity to negative 2.814 on the x-axis, we are above the x-axis. Negative 2.814. Oops. Okay, that's the right bound of this part. So I'm going to negative infinity to negative 2.814, and I'm going to close that bracket because it says or equal to. And then I'll put a little u here because we have this another little piece here. I need to find the zeros, so I'm going to go second calc. And I'm going to calculate the 0. Left bound. Right bound, enter. Guess, yes. I'm going to go negative 0.529. To whatever this 0 is, second calc, 0, left, right, enter, 1.343. Okay, so that accounts for this part here that's above and this bump here that's above the x-axis, or where f of x is greater than or equal to 0. All right. I'm going to use, it says either algebraically or graphically. I'm just going to go graphically, even, odd, or neither. Even, remember, is symmetric with respect to y-axis. Odd is symmetric with respect to the origin. All right, so I'm just going to look at the graphs. Y equals x to the 4th minus 5x squared graph. Okay, that looks like it's symmetric with respect to the y-axis. I'm going to call this one an even function. Y equals, I'll clear this one out, math, math, absolute value, x to the third. All right, let's get out of there and go minus 3 and graph that. That also looks like it's an even function because it's symmetric with respect to the y-axis. And then h of x equals, I'm going to clear this, negative x to the fifth plus 2x to the third plus 4x Alright, I am going to, I want to zoom in on that a little bit. Let's see what that's doing. Okay. I'm going to zoom in one more time. Alright, looks like it has a starting point, but I don't see anything happening over here that would lead me to believe that it's okay, very interesting there. Okay. It does go through the origin. Our pixelation, though, is such that I'm just going to trace this for a little bit. Alright, it's not defined there. Did I write it in right? Oh, okay. Well, this isn't the function, so I thought that looked weird. Did it again. Let's delete. First mistake of the year, guys. Plus 4x. Now let's graph it. And then we're going to have to zoom out of this. Zoom. We'll go zoom 6. That's a standard window. Alright. I changed my mind now that I have it entered correctly. Because I think what I'm seeing here is across the origin, like this point is corresponding to here, that corresponds kind of to that. So I think we're dealing with an odd function. Okay. Now, we're going to write the equations of each of these graphs. I would suggest not relying on the calculator for this. First of all, we know this is an absolute value. Okay. Now, y equals absolute value of x would go up just 1 unit each time, like this. But this one is only going up half a unit as I go over 1. So I think that's kind of a factor there. So y equals x, and then it's not at the origin, it's 4 units to the right and 3 units down. So I'm going to go, remember to the right is minus, so x minus 4, and then 3 units down, that's minus 3. This is a quadratic. That's y equals x squared is the parent function there. 1 unit left, and so I'm going to go x minus 1 squared and 4 units up, plus 4. All right, the other thing to consider is it's upside down, so that's negative. And again, usually it goes 1 and 1, but this is going, if I go over 1, I'm going down 2. So I'm going to put a negative 2 there, is that coefficient. This one's a little tricky because I don't think we dealt with this, but this is the square root function. And it normally does this. 1 and then like 4, 2 is like here. So it kind of goes like this normally. If it was y equals negative square root of x, it would be going like this. It would reflect over the x-axis. This is reflecting over the y-axis. So what's happening is the negative is actually under the radical there. That's what's causing it to flip that way instead of flipping this way. And then I see it's not at 0, 0, it's down 1, so I'll put a minus 1 there. Okay. Now, number 7. F of x is 2x plus 3. G of x is x squared minus 3x minus 40. F plus g of x is f of x, 2x plus 3 plus g of x squared minus 3x minus 40. So I'm going to say that is equal to x squared. 2x minus 3x is negative x. 3 minus 40 is negative 37. I get 2x plus 3 minus x squared minus 3x minus 40. And that's 2x plus 3 minus x squared plus 3x plus 40. So negative x squared, 2x and 3x make 5x. 3 plus 40 is 43. F times g of x, I need to take 2x plus 3 times x squared minus 3x minus 40. You have your way of doing that. I would encourage you, several ways I've showed to do this. I'm going to just try to loop everything over. So that's 2x cubed, negative 6x squared, negative 80x. This is 3x squared. I'm going to put it right under the negative 6x squared. Negative 9x, positive 120. So I'm going to make it 2x cubed minus 3x squared minus 89x plus 120. F over g of x is equal to 2x plus 3 over x squared minus 3x minus 40. Now, the domain of f over g of x, domain of this, x squared minus 3x minus 40 cannot equal 0. So I want to find what makes it 0 and then write the domain, maybe in interval notation. I'm going to factor this. 8 times 5, negative 8, positive 5, that equals 0. Two numbers that multiply to negative 40 and add to negative 3 are these two. I'm going to solve x minus 8 equals 0, which is x is 8. X plus 5 equals 0, gives me x equals negative 5. We can't have those two values because that makes the denominator 0. 8 does, and negative 5 does. In interval notation, I'd go negative infinity to negative 5, u, negative 5 to 8, u, 8 to infinity. That's how we can skip negative 5 and 8. Okay, number 8. F of x is 2x squared, g of x is square root of x minus 9. F circle g of x, I'm going to take f of the square root of x minus 9. So I take 2 times my input, and I square that. That's 2, and the square root and the square cancel out, times x minus 9, which is 2x minus 18. And g circle f. So g of 2x squared, that's equal to the square root of 2x squared minus 9. I don't think I can do much with that as far as simplifying. So I'll quit there. All right, number 9. Show that f of x equals 3 plus 2x and g of x equals x minus 3 over 2 are inverse functions algebraically. So what I'm going to do is find f of g of x, which is f of x minus 3 over 2, which is 3 plus 2 times x minus 3 over 2. 2's cancel, that's 3 plus x minus 3. Let's cancel, and that equals x. So we're good there. If the composites of the two equal x both directions, then they are inverse functions. So g of f of x is g of 3 plus 2x. That is equal to, let's take our input, 3 plus 2x, and let's subtract 3 and then divide by 2. 3 minus 3 is 0, so that's 2x over 2, which equals x. Therefore, f of x and g of x are inverses. All right, so that's algebraically. Graphically, 3 plus 2x. 1, 2, 3 is the y-intercept up 2 over 1. That's the slope. All right, so there is y equals f of x. Now, y equals x minus 3 over 2. I'm going to write that as 1/2 x. X over 2 is 1/2 minus 3 over 2 minus 1.5. Negative 1.5 is the y-intercept. I'm going to go up 1 over 2 from that. Go up 1 over 2 for that. I'll go down 1 over 2. Down 1 over 2. Do that one more time. Do that one more time. Okay. Now, okay, I've plotted those. And now I'm going to plot y equals x. Kind of go, because if I'm going to show graphically, I got to show that it is symmetric over y equals x. And I think it's looking really close to that. Okay. This is y equals g of x. So the two graphs are symmetric over y equals x, which would lead me to say that f of x and g of x are inverses. Okay. Now, number 10 and 11, find the inverse functions of the given functions. Then find the... All right. I'm not going to do that part. Use proper notation. Okay. So g of x equals square root of 2x minus 3. I'm going to first check to see that they're 1-to-1. X minus 3. All right, I knew it would look like that. That is 1-to-1, so let's go ahead and go with it. Y equals the square root of 2x minus 3. We switch the roles here. We solve for y, so I'm going to square both sides. Get x squared. Square and square root cancel out. 2y minus 3. I'm going to add 3 to both sides. I got x squared plus 3 equals 2y. Divide by 2. So y equals x squared plus 3 over 2. And my proper notation is this, equals x squared plus 3 over 2. Now on this one, I got y equals x minus 11 over 2x plus 5. I am curious what the graph of that one looks like. Clear, clear. I got to use parentheses. X minus 11, close that, divided by, paren, 2x plus 5 theses. Graph that. There. There. Okay, it looks like we got an asymptote there, an asymptote here. So I'm around here probably, but with those asymptotes, and I think we have a 1-to-1 function. So x is y minus 11 over 2y plus 5. I'm going to get rid of the fraction here. I'm going to multiply both sides by 2y plus 5. And distribute here. 2xy plus 5x equals y minus 11. Remember, we've switched them around. We are solving for y. So I'm going to subtract 5x from both sides. I'm going to get one side that just has y's on it. And then I'm also going to subtract y from both sides. So I want all the y terms on one side. So I got 2xy minus y equals, that cancels, negative 5y minus 11. 5x, sorry, negative 5x minus 11. This has the y's on it. I'm going to factor out a y from this term and this term, so that gives me y, 2x here, minus 1 here. So I'm just factoring the y out. Equals negative 5x minus 11. Then I'll divide both sides by 2x minus 1. and I have y equals negative 5x minus 11 over 2x minus 1. And if I use the proper notation like I'm asking you to, I go negative 5x minus 11 over 2x minus 1. And there we go, guys.